Alrighty. So do you guys see my PowerPoint?
Yeah, we do.
Yep, I can see it.
Okay, perfect. So welcome to Certs 101. I'm basically going to go through some basics of what certificates are, how they're used, um, especially in the Cisco environment. So I'm going to cover both UCCE and UC as much as possible. There will be some areas that I don't cover, but I'm going to try my best to cover at least the basics and then where to find the information that you need, right? So right here is the agenda, and I'm going to go through all of this with you guys. And in the hopes that, for a lot of you, the basics might be too basic, right? You might already know this, or you should have experienced a lot of this already based on your day-to-day lives, right? What you do day in, day out, renewing certs and troubleshooting. You probably know a lot of this already, but for those of you who don't, hopefully I'll help you gain a better understanding of what certificates are, how they're used, and and how I guess they're used in particular in our Cisco environment. And that includes both HCS, it includes WXCCE, also includes our premise customers. And it's, what you learn from this session, I'm hoping will also apply to non-Cisco stuff. Certs are certs, right? There's nothing um, mysterious about them. What you're learning here will apply to any application or technology that uses certs. So here's the agenda. We're going to start off by talking about the basics, what are SSL certificates and how are they used, the types of certificates. We're going to talk about self-signed versus CA-signed certs, difference between public CA and internal CA. We're going to talk about how root and intermediate certs apply, right? What their purpose is. Um, and then we're going to talk about how do clients, so as an end user, how do they know what certs to trust and what not to trust, right? Browsers, what role they play, applications that consume certs, what role they play. We're going to also have a quick slide about the different formats that certs can be provided to you in, because that's always confusing. Even for me, when I look at it, I'm always having to Google just to confirm, okay, this format, this is what this means, right? This is supported by this technology. So, just a quick overview of that. And then we're going to talk about the different types of certs within the Cisco applications, right? And then we'll end it off by talking about the key knowledge base articles that we have in WXCC and HCS, right, on our Snow, just to see where you can go to find information. A lot of you should be familiar with that already, but I've got that here. And then lastly, the reason we're having this call is because there's been a lot of questions about the recent DigiCert change, right? With regards to them changing the root and intermediate certs that they're using to sign our certificates. So I'm going to cover what that means for us, right? I'm hopefully going to cover a lot of it in uh, the slides before that, but I'll go over the actual link from DigiCert. Okay. Anybody have any questions about the agenda before I go off here? All right. So what are SSL certificates? At a very basic level, certificates are providing identity, right? Both to the server and the client. They are used to encrypt traffic between a server and a client. So server being something like Finesse or CUCM, client being an end user who's logging into Finesse, who's logging into Jabber, right? So that's client. In order for those two to communicate, they're using SSL or TLS communication. And you cannot use SSL or TLS connections without a certificate. Certificates are a fundamental need for setting up encrypted traffic, right? Certificate on the server side is what provides the encryption. On the client side, it confirms for the client that this traffic is coming from a legitimate or a valid verified entity, right? So that's where some of the other, self-signed versus public CA signed certs will come into play, right? Self-signed is basically me saying I am who I am without any third party verifying whether what I'm telling you is true or not, right? And CA signed basically provides that verification, that that multi-step verification to confirm that that cert is actually valid, it's legitimate, it's coming from this place, right? That's the idea behind a certificate. It's to provide identity verification that you're not going to a malicious or some sort of an attempt to route you to um, a bad actor, right? That's going to try and steal your information or get you to input information that you may not, right? Like passwords. So that's the idea behind certificates. Um, a certificate is made up of a public key and a private key. And as the name implies, public can be shared, right? When we talk about trust, when we talk about what browsers can trust what certificates from what public CA, we're talking about the public certificate for those vendors, right? The private is the, as the name implies, should be kept private. That's what stays on the server side. That is what's used by the application that's serving you HTTPS traffic or encrypted traffic. That's what it's using to perform the encryption. It's using the private component. And some of you, again, to relate it back to what we do on a day-to-day lives, right? Private keys, some applications break it up, right? Like a PFX file in Windows contains both the private and the public key, right? PFX is also called EKCS12. I'm going to throw some terms out there just to kind of help you remember them. Later on, we're going to talk a bit more, but you know, a PFX file contains both the public and the private, right? And then you've got some servers that have it broken up into two separate files, public key in one and private key in another. So those are typically, you'll have a .crt file and a .key file, right? Like for example, ICM uses a separate public private key for the internal components, right? It has a separate component. And I believe, yeah, Finesse VPNless or Nginx uses the same type of setup. And I know some third-party applications like Calabrio or Verint do the same thing. So that's an example that we can relate to, right, on a day-to-day basis. So this looks like, so this is kind of what we touched on already, right? On the server side, a certificate is used to encrypt the traffic. So that's the private key portion of the cert, right? A cert, like I said, is made up of two components, a public and a private component. On the client side, it just provides the identity of the server. So we're just verifying that it's coming from a legitimate service, right? So let's say you go to Finesse as a customer, right? The cert that we're using is self-signed. The first time you go to that web page, the browser is going to complain that this site can't be trusted because it's using a self-signed. The reason it's doing that is because the browser has no way of verifying who issued that cert because it's self-signed. It doesn't have that specific self-signed cert in its trust store. And a trust store is basically a, a set of certificates provided or included within the browser out of the box. So when you first install it, and again, I'll talk about that later too, but assume we're talking about Firefox. Firefox has its own built-in trust store, and it comes pre-installed with a specific set of certs. Within that specific set of certs, we don't have a self-signed cert for this finesse server, so it's going to complain. But if you say, it's okay, I trust this site, I approve, right? You proceed, and you load the web page. At that point, the browser is going to actually add that cert in its local trust store. So the next time you go to this web page, it's not going to complain. And that's the way Firefox works. And some pages you will see that no matter how many times you say it's okay to proceed, it still complains. Chrome is bad for that. So that's an example right there. And typically, when we talk about certs, we're talking about HTTPS, but that's not the only use for certs, right? You're talking about any traffic that goes on HTTPS on port 443, it's going to use a certificate, right, to encrypt the traffic. But we know from working on Cisco every day that there's a lot of applications on non-443 ports, like Finesse, for example. The main port is 8445. For CM platform, it's 8443, right? So the port, the well-known port using HTTPS is 443, right? But you can define any port in your application, and it could be using TLS traffic, right? Again, that's just wanted to just something to cover. And out of the box, most web browsers, operating systems, third-party libraries like Java, right? Java plays a big role in Cisco world, will have a predefined list of well-known certificates. This is kind of what I just talked about, right? How do browsers know who to trust? It's based on this, right? This predefined list. And again, just a couple examples of other places where certs are used, not necessarily related to web traffic, right? ADFS metadata, for example, to build two-way trust between the ADFS server and the client. Client could be IDS, client could be CUCM, right? Could be Unity. In order for these two applications to communicate for any SSO related stuff, they have to do a metadata exchange in the beginning. What that metadata includes is a bunch of certificates, typically two certs, right? One for signing, one for encryption, if you look at the metadata file. But those certs are used to build trust between the two applications, right? So what that means is when IDS sends something to ADFS, ADFS knows, okay, this is coming from a trusted source. I can go ahead and process this request. And same thing the other way around, right? ADFS sends something to IDS. IDS knows, yep, this is somebody I recognize. I'm going to allow this to proceed. VPN tunnels is another example. Our eLoyalty VPN, right? We have a cert that was recently renewed, actually. Um, Again, you're using a cert to basically make sure that number one, the traffic is encrypted, also, and also number two, to ensure that you're not getting, um, you're not being scammed, for example, right? You're not hitting an unknown site. You should always be aware, and that's why T-Tech is always sending those training sessions, right? Like the phishing scams. Certs are one way to identify or make sure that uh, you're not going to the wrong website or to the wrong server. So that's basics of SSL certs. I'll pause there for a second to see if anybody has any questions. Okay, perfect. And this is not too small, is it? I'm not doing presentation mode because I like it like this, but I'll make it a little bit bigger. All right, so here we've got three different types of certs, and we use these across our Cisco environments, right? You've seen this everywhere, and this is just a way to identify what type of cert it is, right? And I'm using the Windows cert pop-up, right? This comes in many forms. Each browser has its own way of displaying this information, but this is the way Windows displays it, right? So in order for you to see the type of cert you're using, you go to the details tab and you look at the subject alternative name, and that will tell you whether you're using a single common name, whether you're using a multi-SAN. Multi-SAN means multi-subject alternative names within one cert, or a wildcard. Wildcard is something, as the name implies, using star.verizon.unifiedcxsolution.com or star.ttechcloud.com, right? So let's talk about how these are used. So single common name means that cert can only be applied to a server with the name that's defined within the subject alternative name field, right? So you can't take this cert and apply it to a den01 wx005 fin01, for example. Your browser will complain that the URL that you're going to does not match the cert that's assigned or coming from the server. So, you can't do that. But for now, Finesse doesn't support this. VVB doesn't support this. But if it did, let's say if it did support wildcard certs, right? You could have a star.wxcce.com assigned here, and that could be applied to Finesse. That could be applied to VVB for the same tenant, right? But in this example, this is a single common name, and it can only be applied to VVB. And we'll go over the list of applications that support the common name, single common name, multi-SAN, and wildcard. There's a whole matrix on the WXCCE wiki that's really helpful. So we'll go over that afterwards. The next one is multi-SAN. So multiple subject alternative names. And this is typically used on any VOS application. So Finesse supports this, CUIC supports this, CUCM supports this, Unity supports this. In this example, we've got call manager host names or FQDNs in here, right? So when we generate the CSRs for any of these applications, and CSR, for those of you who don't know, is a certificate signing request. That's how you start the process of getting us a public CA signed or an internal CA signed certificate, right? So in this case, you would define, actually the application will automatically define a list of all the SANs because you're going to select within that application you want to use a multi-SAN, it's going to automatically know that this cluster has this many nodes and these are the host names. So it will automatically populate all of these CUCM and IAM presence host names. But the one you have to add yourself is this one, the last one. This is the load balancer URL for extension mobility. So that gets added manually. Same thing happens on Finesse. Same thing happens on CUIC. The steps we have defined on the wiki tell you to explicitly or manually configure the VIP for that application that you're working on. Finesse has its own VIP, CUIC has its own VIP. You have to make sure that you add that. But the point being, these applications support multi-SANs and you can define as many as you want. I don't know if there's any limits, but I've seen some applications like Google, for example. If you go look at their certs, they've got tens of them in their SAN, right? Microsoft has the same thing. So a lot of applications are using this. So that's multi-SAN. Next is wildcard. We use wildcard within CVP, ICM, and a few third-party applications like Upstream. I think even Verint is using it. So for those applications, we are using the wildcard certs. Wildcard certs are easier in the sense that it's one wildcard cert that gets issued and you can apply it to any server that uses that domain, right? As long as the application supports wildcard. None of the wildcard certs are supported on, I should say, none of the VOS applications support wildcard certs. So we have to use multi-SAN there. But CVP and ICM do support this. So on CVP servers, for example, on WXCCE, we apply the wildcard cert to BXML server, call server, WSM, ops console, IIS, a lot of components using it, right? Luckily, we have a script that does all that for us, right? But all those components need to use the same cert. So it's one single cert that gets applied everywhere, right? In some ways it's easy, but in other ways it's a lot of work because you have to now apply this in a lot of places when it expires, right? Whereas the multi-SAN certs expire at different times for the most part, right? You're not having them all expire on one single day. So it's more it's a coordinated effort to apply the wildcard cert and make sure it doesn't expire, that you get it done in time, right? So that's wildcard certs. Any questions here before I move on? Okay. So types of certificates. This is a continuation of the previous slide, right? So in WXCC, we've got actually both HCS and WXCC we're doing this, but you've got tenant level domain wildcards. They're they're used much more heavily in WXCCE than they were in HCS, but every single WXCCE client will have its own tenant domain wildcard that gets used everywhere. So the last slide that I talked about for CVP, ICM, upstream, variant, all those applications are using this tenant domain wildcard. So in July, when WX005 cert expires, you would go and run the process that's defined in our wiki, right, to renew the cert. We're going through that right now with a few tenants, WX21, 22. We just did WX14 for AFES, right? We're pretty comfortable with it, right? We know what needs to be done. We've got well-defined processes or procedures that tell you exactly what needs to be done. But this is the domain wildcard, the tenant domain. In HCS, you had something similar um, with this one. But HCS, we didn't apply this tenant domain wildcard until unless the customer was on 12.5, because that's the new design that was that they came up with. So 12.5 and up, doesn't matter if you're HCS or WXCCE, you're applying a tenant wildcard on all the CVP, ICM, any third-party applications. Now, there's also a higher level domain wildcard on both HCS and WXCCE. In HCS, you've got something the at the ttechcloud.com and the verizon.unifiedcxsolutions.com level, right? These are used on the load balancer because of the way we were defining our VIPs in HCS. You notice that this is what the VIP for SSO or ADFS looks like for First Bank's um, ADFS, right? To access ADFS, this is the VIP that they use. So instead of saying sso.hc059.ttechcloud.com, which is the new format, right? In the old format, the old design, this is how we came up with the VIP. And so for this to use a cert, you have to use something like this. You can't put the tenant. You can't say star.wx, sorry, star.hc059.ttechcloud.com. You have to use this cert. So this is something we just went through as well in March. So this domain, they both expired in March and we renewed them. And, that was quite a bit of effort because a lot of places are using this. You've got NetScalers, you've got ADFS servers, you've got LDAP servers, you've even got some third-party applications like Upstream using these certs, right? Because they're exposed via the load balancer. And so you you will notice that some of these applications, if you try accessing them using the actual server FQDN, right, rather than the VIP, the browser complains that the cert being used doesn't match with the domain that you're accessing. So for example, let's say you wanted to access the upstream FQDN, right? So this right here is an example. If you wanted to access the upstream server in Denver, you would go den01, HC016, UWF01, blah, 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 right? You put that whole URL, but that URL is not going to match with the wildcard that you've defined on the server because it's not meant to. It's meant to be used by the customer via the VIP. It's not meant to be used. I mean, we use it. We have to use it to access the server from internally, but for the end user, they're using the VIP. They don't get that warning because it matches, right? The cert matches the actual domain that they've entered. So that's HCS. WXCCE, we've got some top level wildcards as well, right? You've got the star.webxcce.com. And this is used on things like sso.mgmt.webxcce.com. It's used on the self-service password reset tool, right? It needs to be used on the wiki, the WXCCE wiki, but it's expired right now. So somebody forgot to update that. That needs to be done, right? And then you've got this one here. This is the multi-tenant in North America. So you use this on Portal, right? So you've got tenant level wildcards and you've got higher level used for core or shared services. Any questions? Okay. So now we're going to talk about the difference between self-signed and CA-signed certs. So anyone can go and generate a self-signed certificate, right? For example, at home, I've got some servers. I needed to have a cert issued in order for some things to work. So I just generated the cert myself. You can use things like OpenSSL, you can use built-in utilities in some of the applications to generate self-signed certs. Like for example, Finesse, any of the VAS applications, any of the Cisco CVP or ICM applications, they all have the ability for you to generate self-signed certs. And in fact, that's how they are first built, right? When you install the application out of the box, they are assigned a self-signed cert. And then we go in and replace them with wildcard or with multi-sig cert signed by public CA, right? So that's the number one thing that's different from a public CA signed cert. So what that means is if you're creating this yourself, there's no third party verifying the identity of that cert, right? No one can validate whether or not it's coming from a legitimate source or not. You kind of have to take the risk and confirm if you want to proceed. So by default, any application that uses a self-signed, like we talked about before, will complain that this site may not be trusted because it's using a self-signed cert. The number one problem I have with this one is ADR, right? Anytime I go to ADR, it prompts me. And this is what I was talking about before. Even though I've added the cert, it still prompts me. Um, Whereas other applications, if you add the certificate to your local trust store, the browser trust store, you can bypass that after the first time. You don't get the warning. But ADR, for some reason, I always get prompted, right? So that's the difference between a self-signed and a publicly signed. One other thing that will tell you if it's self-signed versus publicly signed or public CA signed is issued to and issued by fields. When you look at those in a cert, they'll be the same. If it was public CA signed, those in theory should be different. They should never be the same. They should be different. And with a self-signed cert, you can define the length, right? So it could be 1 year, it could be 5 years, it could be 10 years, 30, 50, 100, whatever you want, right? You can define however long the cert is valid for. So to trust a self-signed cert, any application, whether it be a browser, whether it be a Java-based application like CVP or ICM, right? You have to tell those applications that, hey, this cert is self-signed and I want to trust it. And you do that by adding that self-signed cert's public key to the trust store. And those trust stores can be um, in different places, and we'll go through that later as well. But you can define that cert to be trusted by adding the public key of that cert. So I kind of touched on both of these points already, so I won't go over that again. But let's say, let me pull up the browser one sec here. I'm going to use Firefox because that's the browser I use. So let's say, for example, I go to ADR, right? You see, I'm getting a warning. And this happens every single time. It says adr1.eloyalty.com is using an invalid security certificate. So if you look at the cert, you will see that the common name is adr1.eloyalty.com, right? And this is not a good example. I forgot. We have something called Digital Guardian on our laptops that kind of throws things off. It inserts its own cert. So any HTTPS traffic, because they're monitoring, right? They're making sure that you're not going anywhere. where you shouldn't be going. So anyway, this is not a good example. I'm going to log into the jump server, but you see the common name for the issuer and the subject being the issued to, right, is the same. The common name is the same. So that means both issued to and issued by are the same entity. So that means it's a self-signed cert. That's, one simple way of checking it. If this was issued by a public CA or an internal CA, the common name here would be something like DigiCert or Teletech internal CA, right? Or HCS. And you can see here that the validity of this cert is 10 years. So this was just renewed this past year, but it's good for 10 years. And that's one of the things, right? With a self-signed, you can define however long you want it to be valid. I will tell you this, a lot of browsers are only trusting certs that are valid for up to 390 days, so just over a year. So if you're using a cert that's valid for more than a year or over 398 days, it probably will throw some sort of warning. They started doing this in 2019 or 2020. Apple was, I think, one of the first ones to say this, and then Google and Mozilla followed suit and did the same thing. But that's why DigiCert stopped issuing those 3-year certs. We used to get them. They used to be valid for 3 years. I don't know if you guys remember. At some point, they changed it to 1 year, and that's the reason why. Okay, so next is a certificate authority signed. So this is public CA signed, right? So, well, it's not necessarily public. It could be an internal CA or a public CA, but this slide basically talks about what the difference is, right? How it differs from self-signed cert. So number one, who can generate and sign a CA certificate is limited and controlled. So if we're talking about internal CA, right, that would be somebody like IS who managed the HCS signed certs, right? It could be Teletech own ADCs or their own, I should say, the certificate authority that they have, because we do have our own internal CAs, right? So who has access to those and who can make those, who can sign those certs is limited. And, there's controls in place to make sure that only certain people have access to those private keys. Because the reason for having a cert signed by a public or internal CA is not only do you have um, multiple levels of verification by having a root and intermediate, but you also control uh, the actual private keys for those certs. Those private keys for those certs are very important, and because they're in a lockdown state and limited to a certain number of people, the likelihood of those being breached is low or should be lower, right? So that's why those are typically valid for 10 years, 15 years, 20 years, depending on the type of cert, because they're locked down. The next piece is, so typically CA sign certs will have a root and intermediate sign, right? To build that hierarchy or the chain of trust. So at the top, you've got the root, you've got the intermediate, and then you've got the server certificate. So you your root signs itself, right? Sometimes it can be vetted by third parties, and then the root will sign the intermediate. The intermediate will sign the actual server cert that we're requesting, right? And that's kind of the high level hierarchy or the chain of trust that's built using a CA signed cert. So a client like a browser or Java or any Windows based trust store will have a predefined list of certs, right? Like we talked about in their trust store. By the way the RFC is defined for how these certs are supposed to be managed, a client only needs the root certificate in its local trust store for the site that you're visiting to be trusted. However, from experience, I've seen that to not be 100% true. Sometimes you also need the intermediate to be added to that local trust store. Again, whether it's a browser or Windows or Java, you do need the intermediate as well. But I found a lot of documentation, and obviously it's defined in the RFC to support that. As long as you've got the root trusted, the intermediate will be automatically trusted because it's signed by that root, right? But that's not the case. I've seen that happen in real life. So again, just something I wanted to call out here. So for example, this recent change with DigiCert, right? Using different root intermediate certs. Last week we did a change for AFES. After the change was done, I was testing with Logan, right? Logan had a cert warning when he logged into Finesse or well, no, sorry, not wasn't Finesse. One of the applications that we had just renewed. I think it was CVP or ICM server. He got the warning. The server, the client that he was using, the jump server, did trust the root. The root cert was in the local trust store in Windows, but Edge was still complaining that the site that you're visiting can't be trusted. So we added the intermediate to the local trust store in Windows, restarted the browser, and went to the site again, and it worked successfully. So while it may be true that as long as you've got the root certs on the client machine or the client application, it's not always it doesn't always work the way you expect it to work. So it's very important at the very least for you to add the root certs for any application if it's signed by a CA to your application, right? You do have customers come in sometimes with their own. For example, you've got a customer who has some web services on there and they host them, right? So this is a VXML application you're building as a developer, and you need to consume some services hosted by the end customer. So let's say afees.com. That afees.com cert is signed and issued by one of their authorities that they use. In order for CVP to trust that web service, again, presumably we're talking about something that's HTTPS. In order for that web service to be trusted, you need to import the root and possibly even the intermediate to the Java trust store within CVP. That may be the CA certs, the Java CA certs, and or the dot key store that CVP uses, or both, right? Just for completeness, we might import it to both places. So that's how you make sure that the client is able to trust the cert that's being sent by a server. It's by adding the root and intermediate. And so next piece kind of touches what I talked about in the last slide. A few years ago, all public CAs were kind of forced into only issuing 1 year, max 1 year certs, right? And so that's the current standard. I don't know if that will ever change to even shorter periods, but the idea is to limit risk, right? By having really long, by if you have a cert that's issued by a public CA with a 3 year validity, right? Something could go wrong, it could get compromised, and you could have a bad actor come in and start um, intercepting traffic or using that cert on a malicious website. And so the idea here is to have shorter lengths so you reduce the risk. Having a cert valid for 3 years increases the risk, right? If it's compromised, because you could potentially use it for a lot longer. Having it only for 1 year reduces that risk. And then the next piece, right, the issued to, issued by, it follows a hierarchy or the chain of trust, right? Kind of touched on this before. At the top level, you've got root, and then you've got intermediate, and then you've got the server cert. So what that really means is, and I'm going to use this because it's easier. So actually, none of these certs are, actually, let's look at this. Yeah, perfect. So this is a cert that's on my local computer. It's probably something that the desktop team deploys to all of our machines, right? So this is issued to my host name, my PC's host name. And you can see here, you've got three levels here. You've got the root, so I'm guessing that's RCA, root CA, and then you've got the intermediate CA, and then you've got my server or my machine's host name. So the cert that's on my PC, and you can see here it contains a private key, right? This little message here tells you that this also has a private key. So this is probably used in some ways for some sort of, for some traffic that I'm sending from my machine, it is being encrypted, I would presume, based on the fact that there's a private key here. So this cert has three certs. If you click on this is the root CA. This is an internal CA. This is what the point that I'm trying to make. This is an internal CA. This is only trusted on my machine. If I take this cert and put it on my personal PC, this will not be trusted because I will not have the root CA. I will not have the intermediate CA certs on my trust store, right? That was done by T-Tech. That was pushed by somebody in IT for my PC to trust this, right? So each cert, you can double click or click on view cert, right, to see the details. As I mentioned before, a root CA is typically issued to and issued by is the same value, right? And then the intermediate cert will always be issued by the root, right? Or issued by the root CA. You can see, right? And then the last one here, this will be issued by, this is the one we're actually looking at, this will be issued by the intermediate CA or the certificate. But with each level that you're going up, the length that the cert is valid gets longer, right? I've seen some of the root CAs for DigiCert be valid for 25, 30 years. The intermediates are good for 10 years. Server certs are good for 1 year, right? So that's the way that they're issuing them. Any questions here? Okay. So here's some examples. I kind of touched on the second one just now, but you've got the self-signed. Again, key identifying thing with a self-signed is the issued to and issued by will be the same. Internal CA signed. This one may be a little bit tricky for you to figure out, right? If you don't know who the public CAs are, you could think a public CA is an internal CA, right? There's a very small list of public CAs out there. You could probably Google. You can go on Wikipedia and get the list. There's like 7 or 8 big ones. But typically, if you've got your company's name and the issued by, like we do, we know it's internally signed, right? It's an internal CA. So this one here is an internal signed CA cert. The last one is signed by DigiCert. This example here is still using the old intermediate cert that they just stopped using, right? But this is a public CA signed cert. We're using DigiCert today. I've heard of talks that we might use something called ident trust in the future, which is another public CA, right? So the you you got to be ready for those, right? When we change CAs, it brings a lot of work because you may have to explicitly trust their certs if we're not trusting it already. We've seen lots of issues in the last couple of years related to certs, even with licensing. Cisco decided to change the cert that they were using for their license server, and the cert that they were using on that license server initially was by one party and now it's by another party, and our application didn't trust that new party, so we had to go and apply those patches, right? You guys all remember the call home CA fix that we had to put in ICM CVP servers, right? And I think probably even other places, but that's the reason we have to do that, because they decided to sign the cert that they're using by a different party that we didn't trust.
Oh, hi, Amandeep. So my question, I have one question. So for the chain of trust, normally it's the application certificate expired, right? So when do we need to renew the intermediate or root certificate?
Yeah, so I want to just correct the terminology. We're not renewing root and intermediates. We would import them if they change. We don't do the renewal because renewal implies that we're going and requesting, creating a CSR and then getting it signed. I want to make sure that we all understand that, right? So when we talk about root and intermediate certs, we never renew them. We always import them into our applications. So I think what you're asking is when do we know that we need, how do we know if we need to change or import the the root and intermediate cert, right? I actually did a KB for this. You may have seen this already, but that KB answers that question, right? Essentially, anytime we get and when this type of stuff happens, it shouldn't be like a one-off. It's not going to happen whenever, or like at random times. It's when it happens, we should all know. And we knew about this one like a couple weeks before it happened, but essentially it should not come as a surprise. It's going to be a major change when it happens. And for you to determine um, if your root and intermediates need to be imported is defined in this KB that I'm just going to log into. Basically, what you would do is look at the package that was provided to you by IS, right? That package will contain the cert. And within that cert, when you open it, you will be able to tell who signed it, right? Who was the root, who was the intermediate. So this is the KB I'm talking about, right? This is something I completed over the last couple of weeks. I had started this back in December when I was doing this whole master KB, but I never completed this piece. But this recent change from DigiCert kind of forced me to complete this. But this KB defines for the steps on how to determine if the new cert that you've got will be trusted or not by the application where you're installing it, right? So this example here, you get a package from IS for a finesse server. It contains a CRT file. That's the actual cert, right? And you're gonna open that and you're gonna look at the certification path. And that certification path will tell you who the root CA is and who the intermediate CA is. Then you're going to take those two pieces of information. So you're going to look at the name. You can also look at the serial number to be 100% sure, but you can look at the names and you can look for those names in the application where you're installing it. So that would be Finesse, it could be ICM, right? You would go into that application and look for those certs, the root and intermediate. So do you have the root CA cert that signed the cert that you've got already trusted? So in Finesse, that would be in the Tomcat Dash Trust, right? In ICM and CVP servers, that would be in the Windows Trust Store and also the CA certs, right? The DigiCert Global Root G2, which is the new root CA that they're using, is for the most part, from what I've seen, trusted everywhere, right? This does exist everywhere. This was issued back in 2013 or 14, so it's been around for some time. But this KB defines how you determine if there's a new, first of all, if there's a new root and intermediate cert, and secondly, if that root and intermediate cert is missing from our applications, and if it's missing, how do you import it to the applications? So this KB defines everything. There are some corrections based on some testing I've done for AFES yesterday. I need to make changes to these two sections, but this KB does tell you exactly what needs to be done. And the steps are reusable for any boss application, right? They all work the same with some exceptions. Call Manager has a couple different trust key stores. I hope that answers your question, Wei. If you have more questions, let me know.
Thank you, Mandeep.
Yeah, so this again, these are just examples, right? When you look at a self sign in the certification path, you would only have one cert. Or a CA sign, whether it's public or internal, you will have multiple certs that build the chain of trust. So root, intermediate, and the server cert. And this right here, if it's a DigiCert issued cert, and that's what we should be using for the most part, everywhere that we've got certs assigned in WXECE. There's maybe only a couple exceptions where we don't use a CA sign cert, but anytime we have a DigiCert issued cert, this is what it would look like, right? And you just want to make sure that whoever signed from a root and intermediate perspective, whoever signed that cert, those root and intermediates exist in your application. Okay, next is public CA versus internal CA. So public CAs, are companies like DigiCert, who we use, IDA and Trust, Global Sign, Komodo. There's also smaller ones like GoDaddy, right? You guys have all heard of some of these, I'm guessing. Back in the days, we used to have VeriSign. They no longer exist, but those are the public CAs, right? They have built um, certificate authorities that have been vetted by external parties, right? And they're controlled, they're highly restricted, and they must meet very strict security guidelines for them to be a public CA because it's important for them to keep their certs secure, right? So the private keys associated with the root and intermediate certs that they use to sign our certs have to be kept somewhere offline, right? They're not available on the internet. Because if those get compromised, right? If they get compromised, anybody could become a CA and take those they could take those private keys and start issuing their own certs signed as if they were DigiCert or as if they were ident trust. So who can be a public CA? Somebody that is trusted by browsers, applications, is very limited, right? And it's controlled. Now, I'm not going to say breaches don't happen because they do. That's why sometimes they will go and reissue certs, right? Because some intermediate or root got compromised. I was reading about an example the other day. I don't remember which one it was, but that's happened, right? And that's why it's very important for these to be kept safe. So one of the things with public CAs, because they're public, right, and the whole idea is to have a third-party authority that signs these certs. And if they sign these certs, you want to be able to trust anything signed by those vendors out of the box, right? So that's where they go and work with browser manufacturers or applications like Java and have their root CAs or root certs and sometimes even intermediate certs added to their trust stores. So DigiCert probably worked with Microsoft many years ago, right? To make sure that their root certs that they've got are trusted by default in all Microsoft operating systems, right? They probably worked with all the browser manufacturers too, um, Firefox, Google, Safari, right? So they went to them and said, we would like you to trust our root certs. So going forward, any cert that we issue, and you use Safari to visit amandeepbirdie.com, and it's signed by DigiCert, it would be automatically trusted, right? They wouldn't have to go through the process of manually importing the root and intermediate because the browser didn't trust it. It would be automatically trusted. And the last thing with a public CA is it costs money, right? It's not cheap to get cert signed by a third party. But sometimes, well, not sometimes, business costs money, right? So you gotta you gotta pay the bucks. So the next one, I guess, is the internal CA. This could be anybody. I could build my own internal CA. I can go and start issuing certs signed by a root and intermediate. I can do all that. You can download Key Store Explorer, though that open source tool, and you can do that yourself. You can create a root, you can create an intermediate, and then start issuing certs signed by those two, right? So this could be anybody. The point is, a lot of enterprises like Teletech, um, our customers too, most of them will have their own internal CAs that issue certs, right? Because not only do you have servers, you also have to issue certs to client machines, like in my case, my laptop, right? And you need an internal CA to be able to do that. Certs are used for a lot of things, not just web traffic, right? So most companies, most enterprises will have their own internal CAs, and they mimic a public CA, right? They'll have their own root intermediate certs. But the big difference is that applications or any software that's using those certs must explicitly trust their root and intermediate certs. It's not going to just be trusted automatically. We have to explicitly build that trust. So we have to add their root and intermediate to our application's trust stores. And again, no external costs. And I say that because there's still a cost involved here, right? It's just you're not paying somebody outside the company. You've got the cost of running. You've got people, right, running or managing the internal CA. So it's still costs, but it's cheaper. Just gonna pause here for a second. I know we're coming. It's 9 o'clock now, or 8 o'clock Central now, and I don't know if you guys have to drop. I'm good for another 30 minutes. I would like to get through this today, and then I could do a second session with another group. I did have pretty good audience here, so I thank you for your patience and hanging in there. If you guys are good, please stay back. I will keep going. If you have to drop, I am recording this, so I'll share the recording with you guys and this PowerPoint. So multi-chain CA sign certs, right? Again, going back to the topic of root and intermediate. I've kind of stolen some of the points on this from this web page that did a really good job of explaining, right, describing what the purpose is of a root and intermediate. And this one right here, this one does a really good job because so as you go higher in the chain, right, it becomes more difficult to get the private key, right? Because again, as I mentioned, the private keys for these public CAs are stored offline, right? They're not just available to anybody. There's a specific group of people within that organization who would have access to it, and they would only have access to it most likely to issue other certs. And for the most part, I'm sure all that process is automated. It's not like a human going in and grabbing the root CA for DigiCert and using that to sign our server cert, right? It hopefully is all automated, right? Otherwise, it would become unmanageable. So the point of this quote is that the higher you go in the chain, the harder it becomes to obtain or compromise a private key, right? And that's why the root and intermediate certs are typically for much longer lengths, right? I mentioned the DigiCert root CA is good for 25 years. This intermediate cert is good for 10 years. The new one I think is very similar. This is the root CA, the original, then now we're using the G2. But I believe that's also following the same type of timeline. So I also touched on this before. This was in 2020. Public CA stopped issuing certs valid for more than 1 year. And this was again because of browser vendors like Apple, Google, Mozilla. They decided that it's not safe to be trusting certs that are valid for 3 years. There's even um, concerns with wildcard certs because you could take a wildcard, apply it anywhere. So and that's one of the reasons Cisco has stayed back and not approve wildcard usage on boss applications. They feel that it's not secure. So again, That may change in the future. We're using wildcards in CVP and ICM. They may stop using them there, or it may go the other way. We may at some point start using wildcards on boss applications, but for now, we're not. All right, so the next piece, how do clients know what to trust, right? So this is where this is the most important piece, in a way. This is where a public CA signed or internal CA signed cert comes into play. You can even put self-signed in here and make it trusted, right? But let's start with Windows. So you guys have all done this. I'm gonna remove this. Actually, I'm gonna remove this, start fresh. So Windows has its own trust store, right? Which is what I'm gonna open again and show you guys. And there's a couple browsers like IE, Edge, and Google Chrome. They use the Windows certificate store or the trust store, right? And I keep calling it the trust store, but it's both a trust and certificate store, right? And I'll show you what I mean by that. So when you add a snap-in to this MMC application, right? Certs can be stored in three different places. It could be stored under your personal account that you're logged in with. It could be a service account. It could be a computer account. So I will not talk about my user account because that's not important here. But service account is where you have certs for things like LDAP, right? LDAP has its own service account based certificate store. So when you want to renew an LDAP S or secure LDAP cert, you open service account. And then you go all the way, and I don't have this component installed here, but you would look for something called Active Directory Domain Services. That's the service account. So all this is the list of all the service accounts, right? And when you open that, you will be able to see something very similar to what I'm going to show you here. Same type of tree, right? On the service account. It's again, I'm showing you this from the very beginning because it's important to know how you get here. And you have to select the right type of certificate store. Service account or local computer. So the difference, so this certificate store contains both private key or actual server cert, and it also contains root and intermediate cert. So it's both a trust store and it's also like a Java key store that contains private keys as well, right? So here is where you would typically place any certs that you want to use. And this was just ignore the HC0881. That was me testing something. But this is where you would store any personal certs that could be used by an application. So imagine this was a upstream application server, right? And I picked local computer. You would find a star dot, whatever the tenant wildcard is, installed here. And when you open that, you will see that there's a private key that corresponds to the certificate. And when you place a cert in personal, it becomes available to applications like IIS to use because IIS will store it here. It's either here, I think there's a web hosting one too that I don't have here, but there's usually two places where you can store an IIS based cert. But going back to the article or to that slide that I was just looking at, this is where you put all of the root certs, so trusted root certificate authorities, and intermediate cert authorities go here, right? You can see that the root CA list is uh, pretty big, right? It's got the G2 that we want to use or we're using now, right, for any of the WXCC stuff. But you've also got other certs down here. Let's see if we've got some. You see right here, you've got the T-Tech root CA. So this was pushed to my PC, right? Somebody pushed this. And that's how anything that anything I would visit that was signed by this root CA and this intermediate CA, it would automatically be trusted. right? And you've got a lot of other stuff in here, but the point is this list here is mostly predefined when you install Windows, right? And can be updated afterwards. We can import a cert to it. Same thing with the intermediate. This is where you would have any intermediate CAs. But if I go back to my one of the original points I made, per RFC, a client only needs the root CA cert installed in their local trust store for that site to be trusted. They don't need the intermediate. But from experience, I found this not to be 100% true. So if you're having an issue and you verify that root is there, also check if intermediate is there, right? This is how you do it in Windows. And you need to know which trust store your application is looking at. Every application is different, right? Java-based applications will have their own trust store. They're not going to look at what's in Windows. They're going to look at their own trust store. So that's Windows, right? An example. So and any third-party application like Upstream or Vent will look at the Windows trust store. And as a client, if you're using one of the browsers, i.e. Edge or Google Chrome, it's also going to look at the Windows certificate store. On VOS appliances, you've got the trust store under these entities or these components, right? So when you go to the security administration and you go to the certificates list page, you will always have different key stores listed, right? The server cert always goes into something called Tomcat, right? But anything with dash trust is basically that application's trust store. So in order for you to make sure that finesse trusts the new root and intermediate, you need to add that to the Tomcat trust. In Call Manager, and I don't know the difference on how Call Manager uses these different trust stores, but in Call Manager, you've got both Tomcat Trust, you've got Call Manager Trust as well. And I think they've got some other trusts as well. But depending on the application that Call Manager or Finesse may need to call using those new root and intermediates, you will likely have to add, you have to verify if the root and intermediate exists in those trust stores, right? There's IPsec trust as well that's used for these VOS appliances to talk to each other over the IPsec tunnel that's used for the cluster. But we don't typically have to manage that. The application does it automatically. And on CVP and ICM, we're using Java-based trust stores, right? Java has its own. Was there a question? Okay. So on both CVP and ICM, there's a bunch of Java components, right? And Java by default has its own trust store, and that's called the CA certs, right? As the name implies, certificate authority certs. That's where you would need to verify if whatever root or intermediate is signing your cert, is that trusted or not? So you would do you have key tool that you would use to get the list of all the certs in that CA certs to validate that, right? This process is all defined in that KB that I showed when for the question that we asked. It's in that KB. And then you also have a custom key store or slash trust store within CVP. That's this dot key store file, right? So right now, the process I've defined in that KB, we're importing root and intermediates to both CA cert and .key store. And the reason is because while CA certs is what's used by default, sometimes in some places like Akamai, for example, we modified some of the components to use the .key store as the trust store. And you can do that explicitly through the Java options in the registry, right? You can tell it which key store or trust store to use. And talking to the BU for some issues I've been having, they told me that they're going to move to using .key store in the future completely. So again, we are going to have to add it to both places just to be, because I don't know what Cisco's intentions are for the second one, right? We should just add to both. I don't have Expressway, for example. I don't have Netscaler, for example. They have their own ways of adding root and intermediate certs, right? Um, Once you understand the idea or the concept behind what a root and intermediate does, then it's just a matter of you doing a quick search on Google to say, how do I add root to Netscaler, right? How do I add intermediate? A root and intermediate, they're just different labels. At the end of the day, they're both certs, right? So, you know, y once you know how to do one, you should, in theory, know how to do the other one. Browsers, right? So, as I mentioned, Microsoft Internet Explorer, Edge, and Google Chrome use the Windows Certificate Store. If you're having something come up, a warning come up when you're trying to visit any web pages on those browsers, you want to check Windows Certificate Store like we did here, right? To see if the root and intermediate is trusted, if it's a public CA signed cert, right? If it's self-signed, you should be able to add the self-signed cert into the root CA, the root folder here, and that should do the trick. Firefox has its own trust store, and what I mean by that is, so if I go to settings and I search certificates, look at view certificates, you see this, they have their own certificate manager, and you've got a lot of the same certs that you've got in Windows, right? Here. You see, this is me adding adr1.eloyalty.com over and over into well, every time I visit the site and I say proceed, right? It's adding it most likely to the local trust store. That's what it's doing there, right? Same thing here with some of the expressways. They're using self-signed cert, so they're added down here. Or they're actually not self-signed, but they're issued by Teletech. But you get the idea, right? You've got, this is the trust store. This is where you would want to import any certs if you need to import certs. It's very similar, right? It supports multiple formats. And then these are the actual server certs if we have any, right? These are certs that likely have private keys associated with them, which is what we saw in the Windows Trust Store. And the other thing, nice thing with this one is it should update automatically, right? We shouldn't have to do anything. So when you update the browser, it should update it. I don't know if it pulls a new list from time to time. I highly doubt that. I'm thinking that this updates as you update the browser. Whereas the Windows one, I'm not sure how that one gets updated. I don't know if that's uh, during install, right? Or if there is some sort of a patch that can push new certs. But from what I've seen, the Windows one stays static for the most part until you do an upgrade to a newer version of Windows. And then last point here is that some applications, and I've seen this with Calabrio and probably the same thing with Variant, they have their own key stores, right? That contain server certs and trust certs. So they have their own way of storing that information. And so, well, again, if you understand the concept, then it's just a matter of you figuring out the commands that you need to run, right? A lot of them are using Java key stores, which is a pretty widely used way of storing certs. And you can find lots of examples of how to manage those online, even on our Snow right? Some of the commands we use for CBP might be applicable to those applications as well. All right, any questions before I move on to formats? Okay. So some of the extensions that you might have seen, and also, the extension can sometimes tell you the format that may have been used uh, for that extension, right? So let's start with .key. I mentioned at the very beginning of the call that some applications like ICM, Nginx on Finesse VPN-less, they're using a cert and a .key format, right? Two files that contain the public and the private key. And so this is typically a base 64 encoded file. So it'll say something like begin private key, end private key, and within those two lines you will have a bunch of text, right? Random characters. Um, I'm trying to find an example. Do I have anything open? Okay, this one here, this should do. So this right here is PEM encoded or base 64 encoded. This text right here, right? This is a public key. So a public key will say begin certificate and certificate. A private will say begin private key and private key, right? That's the difference. But they're both a PEM file, a PEM encoded file or base 64 looks basically like what I just showed you. You've got a line at the beginning, and then you've got a line at the end, and within those two lines, you've got this random string, very long string, right? That's the base 64 string for that cert. So those are uh, two important ones for you to know. And PEM is what is supported by Cisco for VOS appliances, right? That's one of the ways for us to import the certs. And I learned that that's what you need for the CVP trust. So when we add the trust certs to the new root and intermediate, they need to be PEM encoded. DER format, which is what DigiCert provided on their website, doesn't work. It corrupts the key store. It corrupts the CA certs. So don't use DER when importing to key stores. But so you've got the key and the PEM. Those are both base 64 or PEM encoded. And then you've got P12 or PKCS12 or PFX. So PFX is a personal file exchange. I think that's what it stands for. That's Windows extension for a .p12. Sometimes you might see P12. Sometimes you will see PFX. So if you're using OpenSSL to convert something to PFX or to take a PFX to convert to something else, um, you should know that it's a PKCS12 format. And PKCS12 is the new interoperable format. It works on multiple systems, right? Unlike some of the other formats that might be out there that are specific to that technology, but this one can work in multiple places. So PFX is what we use to import the wildcard cert to all of our Windows boxes, right? You guys know that CVP, ICM, upstream, variant, they're all using, when IS gives us the wildcard, it's coming in PFX format. And PFX will typically contain the private key as well. That's the nice thing with a PFX. So you could take a wildcard, you could export it from one server as long as it's set to be exportable, and you can define that attribute when you import it, right? As long as it's importable or exportable, you can export it and bring it to another server. So sometimes I've seen people, we have an outage because somebody missed a wildcard cert on one server. Just remember, a wildcard cert is installed in multiple places, so you don't need to wait for IS. If they can't find it or if they're unavailable, you don't need to wait for IS to give you the wildcard. There's a number of different ways for you to get the wildcard yourself. You can go on a server that's got the new wildcard and export it. Hopefully it's set to be exportable. You can export it, set the password, and bring it to the server where you need to apply it and do it yourself. There's also, if it was done correctly, it should be on the shares, right? Either HCS or WXCCE. The cert in PFX format should be available um, on the shares, right? So the point being, there's multiple ways of getting that. This is the nice thing about wildcard and it being in PFX format. The next one is .cer or .crt. These formats can be, this is an extension, I should say. This extension could either contain a DER encoded file or a base64. DER encoded file looks something like this. Like, you can't open that in Notepad. So let's say I open this. This is what I got from DigiCerts website, right? This is what they gave me. This is DER encoded. So if you open it in Notepad++, this is what it looks like. If you open a PEM file, it's more readable, right? There's stuff in there that actually makes sense. I can tell from this one that this is issued to and issued by DigiCert Global Root CA, and this piece here is not even necessary. I could remove all this in this file and only save this, right? And that would be enough. All you need is this. You can take this somewhere online and say decode PEM, and you should be able to get the. Don't do that with private keys, but any public key, you can do this. You can take this online. You can use OpenSSL to decode whatever this contains, right? But what I removed is basically what this contains. This up here, this section up here, what this is. One sec, keyboard's dying. So I hope that helps with the two formats. So a CRT could either be, so again, CRT is just an extension, right? I could rename this to this one here to CRT. Let's say I rename this to CRT and just add a 1 here so it's not the same. So I just converted or renamed the PEM file to .crt, and Windows still recognizes it. So Windows can recognize both PEM encoded files and DER encoded files. In fact, when you do export, it asks you how you want to export it, right? So if I go here, you get to select. So the fact that it can export in these formats, hopefully it also can read these formats, right? So DER is the file that I showed you from the DigiCert website. When I opened a Notepad++, it had a bunch of gibberish, right? Didn't make any sense. Base64 or PEM is the file that contains that begin certificate, end certificate delimiters, right? This is PKCS7. I haven't played around with this one much. I haven't needed to, so I won't pretend to talk about that. PFX is not available because this cert doesn't contain a private key. Remember, PFX is more for certs that contain a private key as well. Okay, so that's how you can verify if it's a DER or base64 slash. Base64 and PEM are the same thing. If I've confused you, that's the same. Base64 and PEM is the same. And then the last format or the extension is .csr. So when you go on a finesse server because the cert's expiring, you actually you actually create a CSR, right? You create a certificate signing request, and that is basically something you send to IS. IS sends it to DigiCert and gets it signed, right? It contains a piece of that cert that tells the issuing party, in this case, DigiCert, this cert is going to be signed. The cert that I'm signing is for this common name, so finesse.com, for example, right? And you can take that CSR file and put it on one of those online checkers to see if it's a valid CSR file, right? It'll tell you all the information about who the organization is, what the common name is, what state it is, what location it is. That's public information, right, for that cert, and you can get that there. And then the next slide, actually, do you have any questions about the formats? Okay, perfect.
Hi, so do we have a list? So which extension we need to import for a certain, like for CUIC finance, or so, because sometimes maybe we don't know, like to DER or PIM, or it's confusing. Yeah.
Yeah, yeah, that's a good point. I think maybe we need to. I don't have a list like that right now, but basically at a high level, any of the Windows stuff that we do is PFX because it's using wildcard, right? Boss appliances will use PEM or base64 encoded files.
Yeah, thank you.
So Windows is PKCS12 or PFX. Boss appliances are PEM or base64. All right, so here, maybe I'll add that way to one of these slides. Your question, I'm going to take note of that. Perfect. So next one is certificate usage in Cisco application. So I wanted to summarize, right, the type of cert that's used in each application. And I'm thinking maybe this is where I add the format as well, because it makes sense, right? What format is supported in each application. So wildcard is used in quite a few places. And I've listed the team and the applications they're responsible for the wildcard here. So UCCE, you've got CVP, ICM, ECE, VPN-less finesse. Third-party servers or applications, upstream Baron, Calabrio, as far as I know. Maybe even Acqueon or LCM uses it. I'm not sure. IS is using it on for ADFS, service communication cert, for LDAP or secure LDAP. They're using it for Windows event forwarding. RNS is using it on the NetScaler for any content switching pips, right? So for things like upstream chat or ECE chat, right? That goes to the load balancer. They're hitting a wildcard cert on the actual NetScaler. They're not using the wildcard on the server. They're hitting the cert on the NetScaler itself. Multi-SAN certs are used in the following VOS appliances and also Expressway, which is probably the only exception here. That's not a VOS a VOS appliance. Expressway is Linux-based, but it's not the same operating system as all the other applications listed here. But Expressway is also using multi-SAN. And lastly, there's only a couple places that are using single common names. VVB is one of them because VVB is not a cluster, right? They're all standalone devices. So even if it could support multi-SAN, it wouldn't make sense. It's a single server, so you have a single common name. IS is managing ADFS decryption and signing certs. Those are self-signed and also single common name. So I wanted to log in. Let's see if I can still log into this. You guys still okay to stay? I need a couple more minutes. I have a lot of content I didn't realize. Sorry, I'm logging into my VDI. So this is what I was talking about. This cert expired and it wasn't renewed. So every step of the way, you get a warning message. All right, so this page, I don't know if you've seen it, exists for WXECE, and it's very helpful, right? It tells you the type of certs we have in use for every single application. So and where they're in use on that app on that server, right? So Active Directory, as you can see here, we're using the domain wildcard for like Gorosoft. But you've got service communications for ADFS. You're using a domain wildcard. I mentioned the token decryption and signing certs for ADFS. They're using single self-signed single common name. You've got all the ICM servers using all the domain wildcards. Ignore this. This is changed since this was initially written. So it's not 2 years. It's 1 year for any of the domain wildcards or multi-domain SAN or multi-SAN card wildcards. Sorry, multi-SAN certificates. But this list here is good for you to look at and determine what type of cert should be in use for your given application, right? Um, there are some applications in here that I haven't really touched much, like for example, the VOS application that's managed by IPT, and it looks like it is using wildcard, but I'm guessing it's probably using one of the core or the higher level wildcards, right? Maybe it's like the tenant domain, or sorry, not the tenant domain, but the multi-tenant domain wildcard. Um, it would depend on where the application resides. But this is a good reference for you if you ever need it for WXCCE. And then the other KB is this one. Let's see. I don't even remember which one that's. Okay. Yeah, that's this one. I'm not gonna go give you a list of a lot of KBs. It's actually this is the only one you need to know. The point of this KB was to have a one place, a one-stop shop, right? Where you come and figure out which KB you need to perform your renewal or cert management, right? So this is broken up. I worked with Mary from IS on this KB, so she contributed a lot to this as well. Um, this is broken into two tables. One, the first table is for any KBs related to wildcard certificates. The second one is related to any single server or multi-SAN certificates, right? And you can see that second table is much bigger. So you've got all of these applications here for wildcard. One thing I want to mention, we as the application teams, so UCCE, IPT, third party, we should not ever generate a CSR for a wildcard cert. That needs to be done by IS. IS has a whole process on how a wildcard cert is generated. They manage all of it. We just need to tell them, hey, this cert's expiring. I need this. And they should be following, IS would then be following this KB here. That was written by Mary, right? They follow this KB and generate this cert and make it available to you in PFX format. So this is the wildcard cert, right? And then once you have the cert, we can begin our pieces, right? RNS has their own KB where they go and apply it to the NetScaler. We have our own KB where we go and apply the wildcard cert to all the ICM CVP servers using the script that Beecher wrote, right? That script can also be used on third-party application servers like Upstream or it has to be tested, but it can be in theory used there as well. The next one is Nginx, right? That's also UCCE. So this defines the KB number, defines the teams required for that change, right? And any notes that we may have. So please, please, please make sure you guys look at this KB. Copy the steps from here. Don't copy old changes. I've seen that happen a lot too. I'm always looking at that when I'm approving changes. Sometimes you guys use changes from the previous year, but the plan or the procedure may have changed. And so look at the KB, use the KB instead, right? Um, I've redone a lot of the UCCE cert KBs, right? All these are brand new. I wrote them from scratch using steps that you guys are using in your changes, right? I took the steps from there, created a KB and a whole process around it, right? So make sure you guys use this because we've got now a step to verify if the root and intermediate needs to be changed, right? So you've got all the checks in here. You've got all the health checks you need to perform, right? All of that is documented here. You've got the backout plan. Everything you need to populate your change ticket should be here, right? If something is missing or something doesn't make sense, you guys let me know. I may have missed something. But this should be your go-to KB when it comes to anything cert related, right? I have a little FAQ section at the bottom too, where I try to answer some common questions, and some of the information that's here I've included in the PowerPoint, right? Like how do I know which applications are using wildcard certs? So that's defined here for WXCC. For HCS, I created a separate KB in Snow. There's no wiki for this. This is in Snow. And this was, I did this last year when we had these wildcard certs, these ones, T-Tech Cloud, Verizon. They expired all at the same time and we had no idea, right? We missed quite a few applications, so there was a lot of panic. So I created this KB then. Now, since this KB was written, we've had a few customers leave or move on to different platforms, right? So the ones with the strike through, those customers are gone. But anybody else, this should be a reference for figuring out where those wildcard certs are used. These are not tenant specific wildcards. These are the core or the top level wildcards we use. So star.ttech cloud or verizon.unified CX solution. So this will tell you not only the application that's using, but also the server names and the URLs that you need to test. So that's for HCS. I also have a little section here on what health checks. How do I know what health checks need to be completed after a certificate renewal? So I started working on this. I did all of UCCE, CVP, but I never finished UC. But the idea here was to have a matrix like this that tells you if you touch any of these components here, right? So if you do IDS, for example, you don't know what applications are you using IDS. Let's say you're somebody who doesn't know ICM, doesn't know finesse, doesn't know anything to do with this. You're just doing the renewal, you're following a procedure that's been defined, but you need to prepare the change, right? You don't know if I touch the IDS, what the impact will be, right? So the idea behind this KB was if you come here and you look at, okay, I'm performing the cert renewal on IDS. So where do I need to perform health checks? Where do I need to make an actual change, right? So HC stands for health check. UP stands for update. And NA stands for not applicable. So update meaning it either requires an update on the server that where the cert is expiring and another application, right? So you're gonna you're gonna update the IDS cert. You need to perform health checks in Finesse, Upstream, CUIC, IDS itself. You need to perform the health check and the change, live data, right? Anything that relies on IDS, you need to perform health checks, right? That's the idea there. Now, for example, this one here, secure LDAP-S. IS goes and does the renewal on secure LDAP, right? We know that LDAP is used in 2 applications. Maybe more actually. Yeah, more than 2. We know it's not used in finesse, so it's not going to affect finesse. It's not used in upstream, so we don't need to do anything there. CUIC, yes, we have a LDAP configuration, right? Um, some tenants who are not using SSO, they import users using LDAP. So we need to perform a health check there. IDS has nothing to do with LDAP. Live data has nothing to do with LDAP. Humanify portal is a key user of LDAP-S. That's how portal creates users in AD, right? So it's imperative that we do a health check there. CCE admin has nothing. AD, we need to do a health check and we need to do the update there, right? The LDAP cert is actually stored on the AD. So we need to do the health check and the update there. CUCM and Unity both use LDAP as well. So we need to do health checks there. The idea behind this KB being, right, it's just somebody who doesn't know all the how far the web goes, right, for a given cert, what the impact might be. You come here and you look at it, right, and determine what type of health checks and what applications do you need to touch with those health checks. All right, so that's that one. And yeah, I talked about the different formats here. I talked about the root and intermediate certs, but I'm gonna take 5 minutes to talk about this as well, right? Because this KB is what I was showing before, and this KB was inspired by the changes made by DigiCert, which is what this last slide is, right? So basically, any cert that's being signed by DigiCert after March 8th, and for some reason Deloitte is an exception to this, WX002, is being signed by this new root and this new intermediate. Previous or prior to March 8th, all certs were being signed with this chain, right? This root and this intermediate. After, it's being signed by this. So again, if everything that I've shown you makes sense, we need to make sure that these two root and intermediates exist in all of the local trust stores, right? And so it's not even if you're doing a cert renewal in Finesse, right? And you know that the cert is signed by the new root and intermediate, you can do the check in Finesse by itself and think, okay, great, I'm good. This is all I need to do. But you may not know that they have upstream, right? And that upstream makes a call to the Finesse server. So upstream makes a HTTPS request to Finesse. So since the Finesse server is renewed, Finesse is going to send the new cert, right, with the new root and intermediate. Now, if that upstream server doesn't trust the new root and intermediate, that request from upstream is going to fail towards this Finesse server, and that's going to cause an outage. Something very similar happened to AFES after we renewed the cert on the NetScaler for them a couple of weeks ago, right? We updated their NetScaler cert, so anything SSO related, ADFS related, was failing in upstream because Finesse because upstream was making a call to the SSO VIP, and upstream server didn't trust the new root and intermediate. So while the change was done in NetScaler, the issue wasn't on the NetScaler. The issue was actually on the upstream server, right? So the point being, you could make sure that your application where you're applying the new cert is trusting the new root and intermediate, but another application could make a call to the one that you're updating and the request could fail. So that's why this change is very tricky. We don't know all the places where an issue might come up. The best way to avoid it is to apply the new root and intermediate across the board in the entire tenant before applying any server certs. Now that process takes time. That's why I took so many changes for AFES, right? We did that for AFES. But going forward, my hope is that we can get ahead. I know that we're always busy, but the hope is that we can start going and applying the new root and intermediate to all tenants who are not even up for renewal yet with their wildcard, right? So let's say, I don't know, WX35, for example. They're not up for renewal till December of this year. My hope is that we can get in there before that date put in the new root and intermediates in all the applications. So we don't have to do that during the actual renewal. Now that's not possible with the renewals that are coming up now in the next couple of weeks, like WX21 and 22 that you guys are working on, right? So we have to kind of do those ones on the fly without. But again, my point being, you could be as careful as possible with the applications that you're renewing, but it could be another application that you haven't touched that breaks because it wasn't trusting the new root and intermediate. So hopefully in the next couple of weeks, we can have a process in place, to deploy this in all the tenants. I've been working whenever I get a chance. My um, the holdup for me was I ran into issues with these two procedures: CVP Java Trust Store and the ICM Java Trust Store. Some of you may be familiar. The key store, the CA certs was getting corrupted when we were adding the new root. We figured that out now. I'm gonna update this KB with those new steps, and I'm actually working on a script as well that will hopefully automate a lot of the stuff that you see in this KB, and you don't have to do this manually. You still have to do it for the VOS appliances, but for Windows, the hope is that we can do this using a script, similar to what you do with the wildcard renewal script, right? Very similar. But use this KB if you're not sure if the cert that you've got, um, if you don't know if the root and intermediate are trusted already by your application, come here, look at this KB, right? It'll tell you the steps for each application, each technology. And I don't touch any non-Cisco stuff in here, but again, it's all the same, right? If it's using Windows Trust Store, I've got the steps in here. If it's a Java-based application, I've got the steps in here for you to run the key tool commands to figure out what certs exist in there. Um, yeah, that's basically it. Any questions on this piece? Or any questions overall?
I have one question here. Myself, Logan. Uh,
Yes.
in the KB, I am just referring Finnish KB, the KB number 16838. There we mentioned while uploading the certificate, we mentioned only root certificate, that is, sorry, application certificate. Select Tomcat and upload the application certificate.
Yeah.
In the current situation, the root intermediate certificates are changed. Earlier it was CA, sorry, CA1. Now it's GL. The certificate is changed. That
Yeah.
should be added, right, manually in the upcoming changes.
Yes. So I had intended to actually add a step basically right before you apply the server cert, right up here, before you add the new cert to Tomcat, to add it just like Cisco steps say, right? Add the root, add the intermediate, and then add the Tomcat, right? I had intended to do that, but I added a step before, right? I added that step here. So when you verify if the root or intermediate are missing, this KB actually will tell you, give you the steps. So you kind of have to combine the steps from the two KBs based on your analysis, right? You have to say, okay, this server is missing the new root and intermediate, so I'm going to come in here and take the steps defined here, right? So I define them here, right? So you add the root and then you add the intermediate, right? So you have to basically take the steps from both this KB. If your change needs to have the new root and intermediate added, you take the steps from here, put them before you apply the new Tomcat cert. Does that make
Okay.
sense?
Yep.
So, you could, I don't know, I guess Cab is looking at this, right? So you would basically say, do this step 1, do the other KB step 2, and that's how you would you always have to do the root and intermediate certs first, because you add those to Tomcat Trust, and then you add the server cert.
Sure. Okay. Thank you, Amandeep.
No problem.
Amandeep, this is Sriman. So I have a question on this one for ICM and CVP. So like I have changed for power core, and Dow Chemical WX022 coming up. So what I've done is in the change step, I have added the new root or intermediate certificate for Windows.
Yep.
First step, and then I'm directly going to use that the normal ICM and CVP update using that PS script. So is that still valid, or do we need to follow different steps after the root and intermediate being added to Windows?
No, that step is fine. So yeah, there's a lot going on. I was hoping to give you an updated script. The PowerShell script that we use for the wildcard, I was hoping to incorporate the import of the new root and intermediate, right? But it's not ready yet. Feature's actually testing still, and I was testing something myself too. But yeah, so if you do it manually, that's fine. You will find that the root already exists from what I've seen in a lot of servers. But again, you have to check that. It may not exist in some places, but the newer operating systems do have that one. It's the intermediate that needs to be added. So yes, you're correct. You need to add those first. One other thing that you will want to add is, I'm going to update these steps today, is these two. Because we also want to make sure that the Java trust stores for CVP and ICM are updated with the new root and intermediate. Right? And maybe for this one, I'll give you my script. When is your change?
Actually, they're expiring 25th. So
Yeah.
I'm planning to do it this weekend.
Okay. Yeah, let me work on that today. So I've kind of got parallel efforts going into this, because Beecher's got his script that does the wildcard cert renewal, right? But I'm working on a script that just imports the new root and intermediate on all the Windows boxes. Because that goes back to my original comment. Customers who are due to be updated later in the year, we want to get ahead and not have to do the root and intermediate during the wildcard renewal. Let's add the new roots and intermediates now. So I am working on a script that will import them. So maybe I'll give you that script. I need to test it because I was so busy working on this issue with the key stores getting corrupted. I didn't have a chance to test it yet, but I've got a script that can import the new root and intermediates to Windows boxes. So maybe you run that first and then you run the other one second. That will simplify it for you. And that script will also import to the key store and CA certs.
Okay, yeah. So then that's
It'll
too.
be easier. Yeah.
Okay.
The idea being, I want to automate as much of as much of this KB as possible, so you're not doing it manually.
Yeah, and like you said, like since we are managing only CVP, ICM, and then the WAS devices, so how do we keep up with other applications like UWF and other things? Because we as ICM or CVP are getting a change and then doing it on one day, and so I think it may break up the other things, right?
Yeah, honestly, again, it took a lot of. It's a very tricky answer for me to give, because we kind of have to say, okay, we have to do it this time this way, and it may cause an issue, right? But that's why we need to have the new process in place, right? We need that script ready. We need to get ahead, and deploy it everywhere. So what I would suggest for your change, if you can, right? So I'm going to give you that script to import the new root and intermediate. And then you're going to use the regular script to import the wildcard. And then the third thing you could do is import the new root and intermediate to all the VOS appliances, Finesse and CYC and IDS. The problem is you have to do a restart of those Tomcats, right?
Yeah.
So it's a lot of work and there's no way around it. And it's a lot of coordination, right, to make sure that it's being done correctly. So maybe you know what, I need some time to sit down and come up with a process, at least for UCCE, and that will take care of a lot of it, right? And if you guys identify that there's some third-party applications on a case-by-case basis, we can review those and kind of and see if those teams can also take care of their piece. But yeah, unless we have somebody that, and I'm gonna try and fill that role, but basically somebody who's overseeing this, right, and making sure that every single tenant we're doing this in the correct order, we should avoid issues. But the ultimate plan is to basically make sure that before the wildcard cert is coming up for renewal, we already have the new route in place, the new intermediate in place. So we're not scrambling during the renewal, right? But yeah, I'll work with you offline on that. I have a script I need to test, and so I've got two things to do today. I need to update this KB with the new commands that we need here, and update KB, sir. Trust KB, test the script, provide, and actually three things: provide high level and to UCCE. Yeah. Okay, I think we're good. Hopefully that answers your question, Sriman.
Yeah.
Anybody
Thanks.
else? Any other questions? Okay. If there's no other questions, I wanted to thank you guys for hanging in there, joining me either really late or really early this morning. I appreciate it. I'm gonna do a second session, hopefully for I'm gonna see. I don't know how many of. Yeah, I'll do a second session later in the day, so I have more North American audience as well, so they have exposure to this as well. So, but yeah, you guys are welcome to reach out to me directly if you have any questions or concerns. And thank you again. Have a nice day, guys. Talk to you later.
Thank you, Aman.
Thank
Thanks,
you.
Aman.
You're welcome.